Today I'm gonna talk about the properties of a function, including intercepts, domain and range, even, order, or neither, increasing, decreasing, or constant. Now let's take a look at the first example. Okay, so for the problem A, how to find the intercepts. Let's go back the definition of the intercepts. The intercepts means the curve crosses over or touches axis, including x-axis or y-axis. Okay, now let's take a look at this curve. It's very clearly this curve cross over y-axis with this point 0, 1. So this point should be y-intercept. Okay, y-intercept is 1. Now again, as we can see, this curve is always approaching the x-axis. However, it never touches x-axis. So that means we don't have x-intercept. Okay, so we can write down the intercepts. We have only one point, that is 0, 1. And B, domain and range. Okay, how to find the domain? And the domain is always about x values. Okay, x values. So we would like to draw an arrow from left to right. Okay, that means x goes from left to the right. Okay, from left to the right, and we try to find the smallest x value and the largest x value. Then we can construct the domain, right? So as we can see, for the left part, the curve always goes left. It never stops. So that means the x value goes to negative infinity, right? Negative infinity. So we couldn't find the smallest x value, but we can see that curve, since curve always goes left, so x value always approach negative infinity. Okay, and then we try to find the largest x value, and we can see the curve always goes up. Correspondingly, the x value always goes right, goes right, or the x value is approaching positive infinity. Okay, so from negative infinity and the positive infinity. And the range is about y value. Okay, it's about y value. We can draw an arrow from downside to upside, and the basic idea is try to find the lowest point and the highest point. Okay, and let's take a look at this curve. We found this curve is always approaching the x-axis. Okay, always approaching the x-axis, but never touches x value, right? So it seems we don't have the lowest point. However, we can see the curve always closing to the x-axis, so that means the y value is 0, right? Y value is 0, so it should be from 0. We use round bracket because 0 is not included. It's always approaching, but never touches. Okay, and now we try to find the highest point. we couldn't find the highest point because a curve always goes up. So that means the y value always goes up, goes to infinity, right? Now, C. The intervals on which it is increasing, decreasing, or constant. Okay, here be careful. The increasing, decreasing, or constant is about x values or x intervals. Okay, about the x values. So we're gonna draw an arrow from left to right. Okay, from left to right, and we can find the curve is always goes up. From left to right, the curve always goes up. So that means the curve is always increasing. Okay, it's always increasing. And what is the interval for x value? So it should be the whole domain, right? From the left to right, it should be the whole domain. On the whole domain, the curve is always increasing. Okay, so whole domain is negative infinity and positive infinity. Now we're gonna check whether this curve is whether this function is even, odd, or neither. So for even, we don't see this curve is symmetric with respect to the y, right? This curve is not symmetric with respect to y-axis. So that means that it's not even. How about the odd? We couldn't see this curve is symmetric with respect to the origin. Origin is here. Okay, so for example, I pick a point here, and then we draw the straight line and extension line. We couldn't find another point here in the third quadrant on this curve. So that means that is not symmetric with respect to the origin. So that is not odd. So the answer for this guy should be neither. Okay. Now let's take a look at the second example. The first one is still about the intercepts. So we're gonna check the curve crosses over or touches axis. Okay, so here we can see the curve touches 2 points. Right, touches 2 points on x-axis, and crosses over y-axis at this point. That is origin, right? So basically we have 3 points. Now we can write down all the intercepts. One is negative pi 0, and this one is pi 0, and this one is crosses over origin. So that is crosses over y-axis, or we can say crosses over x-axis. So here is 0 over 0, 0. Okay, and B, domain. And again, domain is about x values. So we can draw an arrow from left to right, and we try to find the smallest x value and the largest x value. The smallest x value, we can see the curve starts this point, right? Starts this point, and this point has x value that is negative pi. So we have negative pi, and the largest value of x should be here, because the curve stops here, stops at this point, right? So we have pi here. That's the domain. Now let's take a look at the range. The range, we try to find the lowest point and the highest point. Okay, So we have the lowest point here, right, and the highest point here, corresponding to the y value is -7. Here's a -7, so we have -7, and the highest point corresponding to the y value is 7. Okay, and here we use square bracket because this 2 point is included. Okay, included, so we have -7 and 7. Okay, now C. We're gonna check whether this curve is increasing, decreasing, or constant. Again, we're gonna follow the similar procedures like we did before. Okay, so first of all, we draw an arrow from left to right. Okay, that means the x goes from left to right. And let's take a look the trend of this curve. The curve goes down. Okay, go from this point to this point, goes down, and then the curve goes up from this point to this point, and then the curve goes down again. Okay, so it's very clearly we can see there are two parts, this part and this part. The curve is going down or is decreasing, and there are one part the curve is increasing, right? Is increasing. So we can write down the interval, and be careful, the interval is about x values. Okay, x values. So we can write down the for example, decreasing. Decreasing, we have this part from -pi to -pi/2, and then we have another part that is decreasing too, from pi/2 to pi. Now increasing. Okay, and for increasing, we can it's very straightforward, right? It's from -pi/2 to pi/2, right? From here to here. So we have -pi/2 to pi/2. Okay, D. Check whether this function is even, odd, or neither. So let's take a look. This curve is not symmetric with respect to the y, right? It's not symmetric with respect to the y. However, we can see here, if we pick one point here, we draw a straight line. Okay, draw a straight line with the original point, right? And with extension, we can find another point in the third quadrant. In the third quadrant, that on this curve. So that means this curve is symmetric with respect to the origin. So the curve or the function is odd function. Okay, odd function, because it's symmetric with respect to origin. Now let's take a look the third example. First of all, we still try to find the intercept. Let's check the curve. We can say the curve touches x-axis, right? We have 2 points. This point, this point, right? We touches x-axis, and we also have this curve is cross over y-axis with this point, right? This point. So basically we have 3 points or 3 intercepts. Okay, so the first one is -1, 0. The second one is 2, 0, and the third one is 0, 1. Okay, B, domain. Okay, domain is about x values, so we can draw an arrow from left to right. Okay, and we try to find the smallest x value and the largest x value, and we can see the curve starts at this point, right? So the smallest x value gonna be -3. Okay, and the curve stops at this point, right? So the largest x value should be 3. Okay, now let's take a look. The range. The range is about y value. So we draw an arrow from downside to upside. We try to find the lowest point. The lowest point is here, right? Is here. These two corresponding to the y value, that is 0. Okay, that is 0. And we try to find the highest point. Is here. It corresponds the y value, that is 2. Okay, we finish the domain and range. Now we're gonna check the increasing, decreasing, or constant. Okay, we're gonna follow the similar procedure. We draw an arrow from left to right. That means x goes from left to right, and we can see the curve goes down on this interval and goes up on this interval, and it goes down on this interval, and it goes up on this interval. So that means we have two intervals for increasing and 2 intervals on decreasing. Okay, 2 intervals on is decreasing and 2 interval that is for increasing. Okay, now let's write down the answer. So increasing, for example, increasing here is the red one, right? The red one. So it's from -1 to 0. Okay, -1 to 0. And for this part, it's from 2 to 3. And decreasing, that is blue one. So we have blue arrow, right? So it's from -3 to -1. And here it's from 0 to 2. Okay, and again I want to emphasize about the increasing and decreasing is about the x values. It's not about the y value. So x value. Now D. Check whether the function is even, odd, or neither. So let's check whether this curve is symmetric with respect to the y-axis. It's very clearly it's not symmetric, right? For example, this point is not symmetric because this curve here, suppose here, right? If it's symmetric, we should have another point at here. Okay, so that is not even. Now we want to check whether this function is odd. Of course it's not. When we pick a point here, for example, pick a point here, we draw a straight line with the origin point and extend it. We couldn't find any point in the third quadrant, okay, and that means that is not odd, okay. So neither